Well, this program tonight is basically a soils class, and it's a give you the basic information that you might need to begin to work with your soil, identify the type of soil that you might have at your farm or at your home site. And your soils may be different from your front yard to your backyard or to a given field that you might have on the farm, whether it be a hay field or a pasture field. They can vary quite a bit. And so the idea tonight will be, and next week will be, to give you some basic information that will help you determine what soil types you have, as well as how you can manage those. So as you can see tonight, we'll talk briefly about primarily the physical properties of soil. We'll talk about soil sampling. We'll get quite a bit into understanding soil pH and how that is needed for production and quality soils. And I'll talk about the lime sources, which is actually scheduled for the December event, but I'll talk about that tonight. And then next week, we'll get heavily into the nutrients of the soil, NPK, and talk about how they impact production and what changes we can make in reference to fertility and different soils and different plant production systems. So that's basically where we're at with that. I do want to start out and say a special thanks to Dr. Josh McGrath. He's a UK soil specialist that did share some slides with me. I had a good number of slides already put together, but Dr. Jimmy Henning, who's a forage specialist, and I'll use some of his classes to work with the second session there, okay? In the past, I've actually done some soil classes primarily with the Master Gardener. And I actually, let me minimize it. I actually start out with this photograph, okay? So feel free to unmute yourself. I can take a few questions and I ask questions, and you can follow up with comments. As you look at that particular photo, what do you like about it? Is there anything that jumps out about you with that? For the most part,
stuff looks kind of healthy.
It looks pretty healthy, yeah. For the most part, you got a diversity of landscape plants in the foreground. You've got a garden site, and then you've got in the middle of that photograph there some landscape shrubs and a rose garden and some lawn there. In the background, you've got basically some larger landscape species of trees. But as you look at that, one of the keys, and probably the major reason why most of that landscape looks the way it is, could be from the management from it and how it's managed. But in essence, though, it's probably has a lot to do with the soil. So if you follow my cursor, if you go over here in the garden site off to the left, you see some level of soil there. That's still showing, and it's fairly dark in nature, which indicate, more than likely a well-drained, a high organic matter type of soil. But there is one spot that I see that has potential issues in this photograph, and that's over here on the right side of the photograph, about a third of the way up or so, where you see what might be strawberries, and you see some strawberries that are stunted and slightly yellow. So even in this photograph, you have a smaller area that may have potential problems. And a lot of times you don't see the problems or the arising problems in our soil until we get, maybe heavy wet soils or soils that are very, very deficient in pH range or fertility. And then you can see major changes in the productions and the color of plants above the surface. To get it started, the soil is just simply a media for plant growth. And you see a young seedling here germinating, and if you look at the soil, you know, everything that we have on this earth, you know, we are very dependent upon two major nutrients that we have easy access to other than the air we breathe, and that's the soil and the water. And the soil, as we know, is extremely important in our food production systems, whether that be plant or animal production. We're very dependent on the soil as a natural resource for growing media. The soil does anchor, in this case, the plants. They're a foundation for plant growth and development. The soil does contain majority of the water that's needed for plant growth, so it basically is used for transpiration of that and for growth with the water. Oxygen, all plants like ourselves need oxygen, and in this case, the soil contains a good amount of oxygen. And only in extreme cases where we have heavy waterlogged soils or heavy flooding type of situations do we have the lack of oxygen, and that can impact certain plant species pretty quickly. And as you would know, we have a good number of major, it says 17 essential elements, and that we depend upon for plant production, and 14 of those basically are contained within the soil itself. Hydrogen, nitrogen, and carbon being the three that's primarily comes from the air, okay? So as we look at the composition of the soil, we'll break it down into some basic minerals here, and then we'll move up the ladder, so to speak. So the minerals being sand, silt, and clay. We'll talk about those a little here this evening, try to, you know, differentiate, excuse me, on that pronunciation, about how they're different and how they make soils different from the amount of these minerals in the soil. Organic matter is one of the compositions of the soil that we often overlook. And we'll talk about organic matter and, of course, the air and the water that's contained in the soil profile, and how important that is. As we look at organic matter, that is basically decomposing dead plants, animals, and insects primarily that we have in the soil. Now, we can introduce organic matter through such things as manures or compost that we might have accessible to us. We can also, not listed here, we can also grow plants like cover crops and even turnips and some winter type annuals that are often used and tilled into the soil for green manure crops as well. So there's other ways that we can get the organic matter into the soil. So as you look at soils with high organic matter, we often think of them being dark, as you see in the photograph there, very dark, dark brown to black. And as you think of those type soils, you often, I know for me particularly, you know, living here close to the Corn Belt of Ohio and Indiana, if you travel up through those states, especially in the early spring, you can get and see a lot of darker type soils that are much richer in organic matter than our own soils here in northern Kentucky. So the soil organic matter, it basically is a plants and animal residue at various stages of decay. So these are basically considered dead plants and animals, such as roots, you know, leaves, stems, you know, insects, worms, and they are a vital part of the overall fertility and the structure of our soils to have good organic matter. And as these plant materials, especially after they begin to die, they become a food source for the insects and the microorganisms such as the bacteria and the fungi that actually live in the soil. So from that standpoint, it's a great relationship between the plant material that would be on the surface and these soil organisms that make a very viable soil and very productive soil, and a good, healthy soil. So as these begin to decompose, the insects, etc., will actually feed upon them, and then they will release those nutrients back into the soil, and they will become part of the growing media and the nutrients for the plant production above that. Organic matter, if you've ever had any soils that are either too wet, too heavy clay, too sandy, etc., organic matter is a major way to improve those soils. So on a small scale, such as a backyard garden or landscape type setting, we can add, peat moss, those type of materials. You can add, if you want to compost your own food waste, your own, leaves at home, etc. That makes for excellent compost and excellent organic matter that we can incorporate back into the soil. So you can improve the water holding capacity, improve basically fertility of the soil, often by adding organic matter. And we can add organic matter as much as 2, 3, 4 times a year to some soils, especially soils that were able to incorporate that plant material back into the soil. As we look at the different types of soil, and we'll talk about those briefly here, but let's start out with the topsoil. Basically, it's often the darker as you look at the profile here of a soil zones. We see here from the picture at the right, a very deep soil based on its dark color and the depth of the roots that we see here in this photograph. And of course, this topsoil is where most of the nutrition, in most cases, a lot of the fertility, water holding capacity, oxygen is found in our topsoil, and in some cases, the upper level of our subsoils as well. So if you are fortunate to have a good deep soil in topsoil where you actually live, consider that a major blessing in this case, because unfortunately here in northern Kentucky, and I'm speaking of Campbell County here primarily, as we look at some of our individual lands that we have for production agriculture and horticulture, we deal with slopes areas that have been eroded many years ago, and those soils have a limited amount of topsoil. As we look at the underlying layer underneath the topsoil, we call that the subsoil. And in the photograph on the right, you can see a distinctive transition zone from the darker topsoil to the lighter subsoil. And that transition may not be all that evident in some soils like you see in the picture, but often you do have a distinctive transition in color. And that color is due to primarily a couple things, one being the amount of organic matter in that soil and the amount of actually air and water infiltration, and how that soil interacts with those two items. So that helps distinguish between the two layers. The subsoil, in essence, does provide a good amount of storage for water and nutrients, and does regulate to some extent the topsoil from freezing too hard during the winter months, which we're approaching into, or as well as maintaining some level of coolness, especially below 3 or 4 inches in the soil even during the heat part of the summer. So it is a vital part of our soils, and often much deeper in nature than our topsoils. When we begin to look at the physical properties of soil, something that we can see and feel, we often think of these 3 individual items here, okay? Color, texture, and structure. So we'll get into those individually here. So as you look at color, The photograph on the right basically shows a soil with probably maybe approaching a foot of a darker topsoil type material and basically a deep red subsoil. Now, we don't have much red subsoil in Kentucky, but this is a type of soil that you might find in, say, Georgia. You heard of red Georgia clay. And some parts of Kentucky, we do have some red, especially soils. I've seen a good amount of red, and especially southeastern Kentucky and some of the mountainous areas. There you see some red soils. Organic matter obviously is going to basically determine the color a lot, especially in the topsoil layers. We'll get into soil drainage here, but drainage, whether it be a red soil or yellow soil here, would indicate pretty good drainage in this extent here. The amount of oxidation or weathering of the plant material or the soil here also would help in reference to the color that we're looking at. So as you look and begin to break down the colors that we might see, not so much red soils in our area, but if we do have a reddish type soil, that is a good indication of iron in the soil and good levels of oxygen. So as the iron is oxidized by the oxygen, forms like, if you consider this maybe like a rust deposits, rust in this case will give it that red type of color. So if you have a deep red soil in the subsoil and maybe even some in the topsoil, it's a good sign of good oxygen and levels and a high level of iron in the soil. Yellow, on the other hand, we often think of yellow like yellow clay. We've heard that being often used. But in reality, you can have yellow type soils and still have well-drained type soils and very friable type soils. And yellow is a good sign, just like red, of good oxygen levels in the soil. We really like to see black and brown type soils, and we're very, this is, especially the brown soils that we have in the top soils around here, shows a level of organic matter in the soil and for the most part, good to well-drained type soils. Where we get into other colors, mainly the grays and modeling of different colors, is when we get into soils that may be low in oxygen and often a higher level of saturation of water. So we get into more poorly drained or compacted soils. And if you're doing some digging or seeing some soils that might be into the subsoil and have a gray type look or a mottled where you have red or yellow stripes with gray as part of that, that's a good indication that that soil is poorly drained in nature. We see two pictures here. Obviously, one on the left, primarily the soils that we'd have in this area. Once again, this coloration indicates probably a well-drained soil here with the browns here and the reds. And so just keep in mind that color here can indicate to a great degree what we have, whether it be poorly drained or well-drained type soils here, and good oxygen levels in the soil. Here's a couple examples of what you might see in a poorly drained soil. And I actually live here fairly close to the environmental center, and I have some soils that would be similar to what that very top photograph would be. I have an area in my extended front yard close to the garden site that's in a low-lying area, and during the spring and the winter months, it can get somewhat waterlogged in that area. And if I go down there and do any digging at all, I will find some gray soils there. So even though I have well-drained soils within, say, 50 feet of some of these areas, a lot of times it's due to topography and the lack of slope and getting water off of some of these sites that will give you this modeling of gray color. as we began to look at the texture, and I think when you think of texture, think of sandpaper, okay? So we can go to our hardware stores and buy different courses of sandpaper. Would that be a real gritty or a real, coarse sandpaper, or we can buy a real fine sandpaper that's often used to help smooth things off to a more smoother surface. So in essence, we find a lot of these sandy type soils along creek and river bottoms, primarily, where we'll see a lot of movement of water that basically where all of those soil types originated, and we'll see a lot of sandy type soils there. Sometimes you get into fields that may have 2 or 3 feet of topsoil, not much at all subsoil, and you get right down to a bed of sand. And that's sort of, I've got a garden site that has that, and it has a good amount of sand within that 2+ feet of topsoil. But once I get below that soil line, I actually get right into a bed of sand. So in this case, sand can be right at the surface, or it can be maybe 2 or 3 feet down, depending upon how that soil type was developed. Sand, we'll see here, comes in a lot of different sizes, and we'll look at that. But if you've got a real coarse, gritty type field in your topsoil, if you rub it, on your thumb and fingers there, and you feel that, you can almost indicate you've got a real heavy sandy type soil. And of course, as you can figure, sandy type soils don't hold water that well. They're good for moving water through the soil horizon, but not too good in retaining a lot of water as far as plant use. So in some cases, if we get a soil that's say 50+% sand, it can often be more of a drier type soil during the midsummer type growing seasons. As you look at soil, just to give you an idea based on the sizes of the particle size here, and this shows the very large sand being a very coarse sand, and it shows 2 millimeters. And there's 25 millimeters in an inch. So just to give you an idea, that would be, basically 1/12 of an inch in size in a very coarse sand particle, okay? Would have very little, if any, nutritional value for soil, would have some level of infiltration of water capacity here, depending upon the percent. But for plant growth, limited and almost no nutrition, obviously, coming from these larger sand particles. If you move down through that photograph, you see some very fine sand particles listed at the bottom, a very small fraction of the 2 millimeters. And even here, we've got medium and medium sand shown by the lighter brown, bigger circle at 1/2 millimeter in diameter. And as you look at silt, being the next largest type of soil particle, being considerably smaller. And if you look at what they're showing for clay, it's not even a dot on the paper. So we'll cover those here in a second. Silt is by far what you sort of like to see a lot more in your soil mix, okay? And in this case, the particle size is 0.05 to 0.002 millimeters. It's very small, and for the most part, except for maybe the largest of these silt particles, you cannot see them with the naked eye, okay? Whereas with sand, it's very evident here in this case. And so if you were able to work with your soil, especially if you had some fairly well deep topsoils, you'll find out that quite a bit of that is made up of silt in this case. And as you can see, what the individual's doing there with that soil in their hands is they're trying to form what's called a ribbon. And you'll see that with clay here in the next photograph. But In this case, you see if you was to rub it and try to push it away from you, it's going to basically, you might get a really short ribbon, but it's going to fall apart. It's going to be very smooth and to the touch there, especially when it dries, very flowery. It's going to be slick, but it's not going to be sticky. So if you were to walk in these kind of fields where if it was muddy, say, this is the type of soil that's going to, you know, stick to your shoes a little bit, but it's not like it's going to stick to your shoes and form great big clumps around the sole of your shoe. So that's a little bit of an indication of what high silt soils are going to be. On the other hand, we often think of clays as being sort of, you know, the worst type of soils, and too much clay is bad, but in reality, some level of clay particles is very important in the soils that we have and the soils that we often will try to manage to improve soils that might have a fairly large percent of clay. Clay particles are extremely small, only able to see those individual particles with an electron microscope. And they're going to feel smooth and very powdery when dry, and they become very plastic type where you can form and make, you know, balls and almost like Play-Doh, and very sticky when wet. So if you've ever walked out into a field when it's really wet, it's heavy clay, obviously after a couple steps, your feet, your shoes are going to be weighed heavy with clay particles because they will stick to your shoes and form quite large footing surfaces that just retain to your shoes. Also, you can see there that they have formed a ribbon, and that ribbon makes, you know, if you was to move that through your fingers and thumb there, sometimes that'll extend out without breaking off 2 or 3 inches from your fingers. And if that's the case, you're looking at a fairly high clay type soil type here. One way that you can do this at home, and you can begin to get a feel for what soils you have. Let's say you have a garden site that you really are looking to develop, and you can go down there in an area and get maybe a half a quart or so of soil from that area. You can actually put as much water in there and actually take a large spoon and try to mix as much of those soil particles up with the water, okay? Try to get as much of those individual particles dissolved in that water, and then just set it out off to the side and let it sit for several days. And what's going to happen, the soil particles will begin to separate themselves fairly quickly with sand. It being the largest and the heaviest of the soil particles, it's going to fall out to the bottom of that jar first, followed by the silt, and lastly by the clay. So it's important that you get it dissolved as best you can, and then once after maybe a week or so, most of that, even the clay particles, will filter out and settle to the bottom of your jar. Then it'll make it, you can actually see layers within that jar. You can have, you know, a thin layer of sand, or even a thick layer of sand, depending upon the amount of sand in that sample. And the same thing for the silt and the clay. But it will be distinctive layers based on that very simple process. Soil particles, we mostly like to see a large percent of clay and silt in our soils that we work with. That provides the best water holding capacity of soils and the ability for those soils to hold and supply nutrients for plant growth and production. And you can see there from the bottom, you know, a good soil, an ideal soil, is going to be about 25% sand, 35% each of silt and clay, and about 5% organic matter. That's sort of an ideal situation. most people would be very pleased with something similar to that. But this would probably be what you would have with some very deep, loamy type soils that might be river bottom soils up from the main, lower bottoms up in the second bottoms if you have those, but still some level of sand, but somewhere in the neighborhood of about 25%. And you may have seen this, and I can give you literatures, that would give you more in depth about each of these areas. But if you had a feel for how much sand, silt, and clay you have in your soil, you can really go to this triangle and begin to give an idea what type of soil you would have. And a lot of Campbell County farmers are going to say automatically that they have clay soils on their farm. And that's a lot of truth to that, but in reality, a lot of our soils is sort of silty clay and maybe silty loam or clay loam type soils. So we may not be as bad as we think as we are. Unfortunately, we just don't have the soil depth of the topsoil that we need in some of our fields, and especially fields with a good amount of topography. All right. Okay, structure. I think of structure as like, Legos, where you take small and bigger particles and how those particles fit together. They're going to build something. But in case of the soil, it's how those particles of sand, silt, and clay form to make, larger soil particles. So when you cultivate your field, you actually are working up the structure of that soil, okay? And the percent sand, silt, and clay and how they form will basically distinguish between the soil structure. And soil structure is a vital part of the soil that we can look at and see, and we can over many years have some level of impact upon soil structure. Soil structure, as you see, is extremely important in the air and the water movement. The availability of plant nutrients quite often is determined about how the soil structure. So the very bottom says examples of that is granular, blocky, columnar, and plates. And most of the soils in our area are going to fall under that granular to blocky, okay? Mostly granular soils are going to be those high organic, fairly deep type soils. We find more of the blocky type soils and soils that are going to be higher in clay content. Not too much columnar soils in our area, and maybe a few soil types that might be in plates. But one of the biggest issues we have with platy type soils is that sometimes through tillage or surface, we can actually form plates in compacted areas in our soil. We'll talk about that later, all right? All right, I'm gonna make a few more slides and then we'll take time for some questions. All right, so this is what granular soil type would look like. Primarily, you can see here from the picture, you have smaller particles, not even about half the size or less of raisins, let's say, some maybe as big as raisins, but they basically fall freely apart. In this case, if the soil had a little bit of moisture and granular type soils, if you tried to make, squeeze these together, they would, when you open your hand, in most cases, these soils would still just fall apart in your hand. So they're often in topsoils and some layer of good quality subsoil still may be granular in nature, but most of our good loamy topsoils would have granular type of soil structure, okay? These particles are sort of rounded in nature and somewhat small in nature as well. When we move into larger granular particle arrangements, we're looking at blocky and and the picture in the individual's hands showing some fairly large blocky type soils. And once again, this would be soils that would be more high, often more high clay in contact. So that clay, which has a lot of negative bonding, will actually help hold together these individual soil particles and form these individual clumps of soil here. So they're going to be often sort of square, blocky in nature, some sharp edges, flat areas, as you can see here. And we often, once again, see that in a larger clay content and often in subsoil layers as well. Platy, not so much. We can have platy type arrangements, once again, where the soil particles are somewhat horizontal in nature. And this can be caused by a couple things. One being just how that soil is laid down. If you get into some areas where we have some flooding, and that flooding especially comes from soil particles that are maybe have a fairly high clay content. And as that soil filters out from the flooding, it will filter out in layers like this. And we can get some level of layering in that soil from different floods from different periods of time. Another thing that we are looking at is obviously compaction can give you those layers, and those layers can and will have a major impact upon the air and water flow and systems in fields. I won't get too much into this, but another platy type layer is called a fragipan, and that often is used from tillage. And that could be, you could have good topsoil, fairly with limited clay. You get down into maybe some level of starting to get into clay layer. And if we work that, even with a farm disc or even a field cultivator, will that be a rotavator or even your home garden rototiller, you can actually form a thin layer of very solid plates that can and will resist air movement and water movement and actually root movement. So I've got a few slides next week that I'll show that. Okay. So in essence, the ideal soil is going to be made up, of about 50% of that soil volume is going to be the minerals itself, sand, silt, and clay. And the rest of that, those minerals are going to be, or that space is going to be pore space, okay? And some of that's going to be very large pore space that might be left from, let's say, from earthworms as they move through that soil profile, or maybe where we had some root systems that may have died away and left fairly large pores. And these are pores that we can often see as we dig up soil. I mean, they're very evident. The smaller pores could be, individual cracks or crevices in the soil in between the soil particles. May not be quite as evident to the naked eye, but in essence, very vital for water and air movement in the soil and retention of that as well. Now, what we get into is when we begin to see environmental conditions that either we as humans impact the soil, or whether between, very, very drouthy situations or very wet periods of time. So we can actually move the amount of soil minerals, increase those. We could increase or decrease the percent of water and air in the soils. And that can change naturally as we move into winter here. Our soils become a little more heavy with moisture due to the less evaporation and the movement of that water. So an ideal soil during the summer may not be quite so ideal during the deep winter or early spring so much. So it can change. As we compact soils, actually what we do is we increase the soil mineral content in a given volume of soil, while we're decreasing the pores needed for air and for water. Okay, so this little circle on the left-hand side would probably be a soil that was a heavy soil, possibly a real heavy clay soil that it was fairly compact, and obviously not a lot of air space in between those soil particles. So that would be a good example of a water saturated or a compacted type soil. A couple more slides and then we'll take a break for some questions. As we look at this internal structure, okay, it's extremely important to have good structure. We're looking at trying to maintain water permeability. So if we have poor internal structure, then we're often going to have a soil that's somewhat waterlogged in nature. We may even have standing water that's 1, 2, 3+ days after a significant rainfall. It's going to be wet this time of year to walk across. Water can still be on the surface. We can have very high water tables within this type of soil. Soil that would be crusting easy could have a poor internal structure or drainage, okay? And then often we can see poor plant production from these soils as well. And once you lose structure, folks, it's often somewhat hard to rebuild, especially if we destroy structure and compact structure deeper in the soil profile. If it's a surface compaction, sometimes freezing and thawing over a winter can reduce the impact of that low-grade compaction at the surface. But if we compact soils down 3, 4, 5, 6, or even 6, 8 inches with tillage equipment especially, sometimes it can be hard to break that back up and improve the soil structure. All right, I'm going to stop there, and I've covered quite a bit of material just on the physical properties. Is there any questions you might have on that before we move into soil testing? Any questions at all? Okay.
Yeah,
Go ahead.
A question about the percentages.
Yes.
Are the percentages you're talking about of the sand, the silt, the clay, and the organic matter, are those based on a certain volume, or are they based on weight, or how do you
They're
figure?
based on more volume. Yes, that's a good question. They're based on the volume. So if I had a gallon of soil, if I was to go out there and take a shovel and dig up, approximately what I could get in a gallon container, and we divide that up into, first of all, solid material and air and moisture particles, then yes, it would be based on volume, not weight. And that,
another question. So if I had some quantity of sand and decided to mix that into the clay that I typically have to work with, am I going to mess up the soil structure somehow, or will I loosen it up, or am I going to get concrete out of this?
Yeah, actually, that's another good question. In high clay soils, you would take a tremendous amount of sand to make a major impact upon that soil and its ability to have, larger pores, improve the drainage of that. It's hard for me to say, how much in a given volume you'd have to add sand to, but in this case, you would think sand would be a very simple solution to wet, heavy clay soils. It can be, but it takes a lot of it. In a lot of cases, we're trying to break those clay particles up and separate them, and organic matter is by far the best way to do that. Okay.
Thank you.
Does it pay to add earthworms or other worms?
On a small scale, yes, you could do some of that. On on a small scale, but in reality, when you're looking at larger scale, quarter, half acre, whatever, you would have to add a lot of earthworms to those type areas to see a major difference. Now, I've seen the old traditional night crawlers we have out there, which are much larger, and if you can get those established in some of these areas, they make a much larger air and infiltration sites, and they could have a little bit more impact upon aeration and water drainage, especially in our clay soils. But unfortunately, they're going to move away from those soils and try to establish themselves in a more friable, more high organic, high soil type in that case. But could be on a smaller scale if you have smaller volumes that you're working. Okay, thanks for those questions. Soil testing, on the other hand, is something that I have promoted. I think every county agent in Kentucky promotes on an annual basis. Soil testing is something that most counties, I think all counties in North Kentucky, do as a service, as a free service to all homeowners and landowners and farmers alike. And it's something that, in fact, I had some come in today. We had some, and I've got probably 15 or 20 samples that are outstanding yet to come back from the lab. So in essence, if you are concerned about your soil and you want to get a good feel for the fertility and the soil pH of the soil, then soil testing is something that you need to do. So if you want to manage it correctly, start out with a soil test, and then we can move from there. So it's an important part of achieving good production, good yields, and if you're production, agriculture, horticulture, a major important factor into profitability is to test your soil and understand what it needs, if it needs anything at all, okay? As we begin to look at soil testing, what we're really looking at doing is where do we stand on pH? Do we need to adjust the pH? And that has limestone on it, which would be for increasing pH. But I think, Phil, you had said you were growing blueberries, so obviously having a low pH there is important, and it sounds like you're managing with that. A couple of the major minerals, we'll talk about these and some others, phosphorus and potassium, are extremely important and often larger volumes as far as quantities for most plant production. We do get into some other macro and micronutrients, and we'll talk about some of those briefly, but when we do some soil testing, we are looking quite heavily upon what's the soil pH, what's the phosphorus and potassium levels. Rarely do we ever test for nitrogen. It's something that is basically moves in and out of the soil quite freely. And so we've got to grow plants that either don't need much nitrogen, add nitrogen if it's needed in either inorganic or organic form, or grow plants that have called legumes that can produce their own nitrogen. So we'll cover some of that nitrogen later on next week. But if we look at soil testing, we'll break it down into 4 major factors, and that is the soil sampling. Now, soil sampling can be done by yourself, okay? Or it can be done by the county agent. If you've never done sampling, you want someone to come out and work with you on it, we're glad to do that as well. And then we've got basically the soil analysis, and that is what's going to come from the lab, and then being able to interpret that and to make recommendations on that. So we're going to cover those in this next section. And soil sampling by far is the biggest step in making sure that we get a representative sample of the soil that you have in the sampling area, whether that be a small garden site or 20 acres in size. Making sure you get a representative sample is going to be important. What do I mean by that? Well, one of the things you got to do is determine what area that you want to test, okay? And depending upon your site, that may only require one sample, or it may require several samples. So I will try to explain that to you. So as you look at this field area, this over to the right, top right there, you see different topographies and potentially different soil types maybe. We often might see different cultivation, different plant materials growing in different locations on a given larger site, or maybe even a small site even at that. So often when we begin to say, okay, what area am I going to sample and what area do I need to pull soil cores from, we often look at it from a standpoint, is the slope very similar in nature, okay, which is often a factor. Is drainage very similar in these areas that we want to sample, okay? And the past management, was it in a same similar crop? Was it in a grass crop? Was it basically in a garden site prior to this? So those things come into play as you begin to look at a field or 1,000 square feet or less of how you want to pull samples. But keep in mind, you know, sometimes it's better to have more samples early, even if you have a fairly large uniform field. If you know from the past it's got different areas that grow better crops than other, then you can basically distinguish between those and separate those into different samples so as to get basically a better feel for individual sites, okay? So once you determine based on soil, slope, drainage, past management, crops that you want to grow in certain fields, then you can begin to visualize, you know, areas that you want to include in an individual sample, right? So if you follow my cursor here, and let's say that's number one is a fairly level, well deep soil, okay, in a bottomland. And let's say in sample number one, we had alfalfa in that field, right? Now sample two, which may have a very similar type of topography, and we might say, well, it's close, but in the past, we've grown corn in that field, okay? And so as we begin to sample these two individual fields, we would not include them, even though they're the same topography and maybe, you know, same drainage, etc. We would still want to separate those into two samples. So that's just one analogy. And as we move up the slope, as you follow my cursor, as we move up here, we change slope, then we also want to separate those fields based on slope as well as maybe the type of plant material that might vary or may not vary within that slope, okay? And then if we have some ridgeland, which in this case would be the very top, let's say that might represent some very top ridgeland, then obviously that would represent a sample beyond just the slope area itself. So make sure you break the larger areas down into smaller fields based on those type of areas, okay? When you go into these areas to sample, it's important, if you follow the picture on the right of my cursor, it's very important that you go in what we call a zigzag fashion. And I'll show you the next, I think, slide is a sample of the soil probes. We do have soil probes that would make the sampling very easily, right? You would want to stay away from maybe wetter areas that would be different, or different areas that might be different within this field. So if this field had been in cultivation, you'd probably want to stay away from the very ends of the field, because sometimes you have a tendency to fertilize those a little heavier than you might out in the middle of the field. So in this case, you would take a plastic bucket, your soil probe. You can do this with a shovel, but it's not quite as easy. And you would just take individual cores throughout that field, trying to get upwards to 12 or so individual cores from a field that might be as small as a quarter of an acre, maybe a few more if that field was pretty uniform, even as much as, 10 to 20 cores in a 5-acre field, let's say. So those cores put into a bucket, but basically, and you would mix them together, and that would become a representative sample of those individual fields, okay? Also important that you basically would, either on a paper or pencil, or if it's just a couple samples, make sure you mentally or physically record what sample 1 would represent, whether that's field behind the barn or a field out front of the house or whatever the case, so that we have that information and you have that information to refer back to, all right? How about soil? How deep do you want to core? Well, if you've just got some open pasture fields, okay, 4 inches is all we want to go. So the smaller photo insert over here shows what might be a plug of about 4 or so inches deep. Okay, if you're going to till this field, meaning you're going to cultivate it, turn it upside down with a plow, etc., disc it or whatever, move it around, you may want to go to the depth that you're going to plow or cultivate that field. So this could be as deep as 6 to 8 inches, depending upon your tillage equipment that you might have on the farm. On the other hand, if you're looking at a garden site, lawn site, usually, around that 4 inches for a garden. If you're going to plow that garden, you can go all the way up to 8 inches, depending on the depth that you might have. If you're going to go with a rotary tiller, usually 4 to 6 is adequate. And in most cases, if you're looking at a lawn site, 4 inches in depth is plenty in that situation. So just caution you not to go extremely deep or extremely shallow in your sampling techniques. If you do, you might skew the actual results, and the soil may not be close to what the end lab results might show, due to the fact that you went extremely deep or very shallow. Right? Now, things you'll need, of course, is a plastic bucket, maybe some quart Ziploc bags if you're going to take several samples. In this case, try to do it, this picture is not a good picture. I got that slide from one of the soil specialists, and it's a horrible picture in reality of people taking soil samples. First of all, it's wet and muddy there. The crop is already approaching knee-high, which means we're already into the growing season, but the gentleman in the yellow top and pants does have soil probes that he's got, I think, in his right hand and on his left shoulder there. So these are part of the tools that you'll need to make real good soil samples, okay? Air dry these at home. Avoid taking them when they're really wet and nasty and muddy, because when that does dry out, if you've got clay, you're going to have bricks, okay? And hard to break up. We will take your wet soils if you bring them into the office. But we basically have to dry them out and process them out there in the office, which is not a big deal, but if you can do it at home, you make us happy in the office, okay? Some of the things we're going to ask for when you come in, and you can provide these in advance on a piece of paper, we're going to need basically the crop to be grown in this particular soil area. So that could range from grass to a forage crop, a grain crop. It could be a flower garden, perennials in your garden. It could mean basically your landscape plants or your home garden. So we'll need to know that, okay? And if it's a production agriculture crop, we'll often want to know the previous crop that may have been in. So if you're going to have, let's say, a field of alfalfa, and it was in corn the previous year, that's going to help us with the final diagnosis of recommendations, okay? We're going to ask you whether this is an annual top dress or a new seeding. So if you're doing a new seeding, let's say in a lawn, we need to know that, or it's helpful if we know that, so we can make the recommendations based on a new seeding. If this is something that lawn's been in there for several years, and you're just checking the soil for fertility and the pH, then basically all we need to know is it's going to be an annual top dress or an annual application of fertility if needed, okay? In some cases, we might need to know about the soil drainage, and that would range from very poor drainage to moderately well-drained to well-drained type soils. And we'll be asking you how many acres are in that field or how many square feet, it might be available. That can be your best guess, or in some cases, I can provide you with a hand tool to measure with, meaning basically a Garmin. You can go on GIS, Link GIS, excuse me, and you can go in there and pick out your soil map, soil area that you want to test. Drop a few pins, draw around those, and it will calculate the acreage or the square footage in the area that you highlight, okay? So you do have a way of actually determine very closely what you're dealing with. Here's some samples that I got today. On the left-hand side, you see a Ziploc bag. This is a quart Ziploc bag, and these samples have very much adequate amount of soil per sample. I've got 5 of these in today from one individual, and this is what they look like when he brought them in. So he had already had crumbled up any larger soil particles down. And the photo to the right basically shows what those samples look like in the individual areas for drying. So you can see the soils, they're probably what we call granular in nature. There's no big clumps in those. You can see through that plastic Ziploc bag, the small soil particles that it actually crumbled up in. So that structure would be basically granular in nature, no really big heavy clumps that you would see with heavy clay. You do see a little bit of difference in the color, and these were just how they came out of the plastic bag. So if you look at that one sample in the lower right-hand corner, it is noticeably darker than the other, and therefore more than likely has an increased amount of organic matter in that particular field. Once again, we're going to ask you a few things, and this was Gene Dobbs' soil that he brought in, and this is what he brought in. He's done enough soil samples in this case in the past that he is able to know what we need as an extension service. So he has sample 1 being a hay field, 4 acres, and it's alfalfa orchard grass. It says here that it's recently established, and that he established some orchard grass in this field, same field, in the fall of 2020. So he seeded in the spring with alfalfa and came back and put orchard grass in that same field in the fall. So that's good information for me as an agent to know, okay? And as you highlight the other samples, they predominantly was also hay fields, a mixture of some cool season grasses, fescue, orchard grass predominantly, with some level of clover, okay? And the level of clover is important here because it will determine whether I include nitrogen as a part of the recommendations or not, all right? And so it's sort of a guessing game on the farmer or the landowner or the homeowner, how much legumes it might be in that particular field that's being sampled. It could be none, or it could be, 90% or more, and it will make a difference how we write them up, right? All right, any questions on this? I'm going to get into what we're going to see in a soil sample, but in the soil testing, any questions you might have there? The main thing that we're looking for is a good representative sample. So don't go too deep, don't go too shallow, in this case, with your soil probes or your shovels. All right, we take samples all year long. It's not a spring or a fall type of scenario. I like to get samples in during the fall because if we have a need for changing the lime pH recommendations here, we can make adjustments now that will impact the crops next year when they start to grow. Depend upon the fertility that's needed. In some cases, it's good to put down some level of fertility in the fall to help root development during the winter and to have a better and quicker green up come spring. Right? Now, this is what you're going to get. All right, so the soil samples, you bring them in, we dry them down, we send them to Lexington to the soils lab. In as little as a week, predominantly more like 2 weeks this time of year, maybe a little bit more even in the spring when they get a major rush on soil sampling. But here's a couple things you're going to see on this sample. A lot of this we pull from you and some we don't. So here's, if you look up here under the owner ID, this particular individual, sample number 1, and he's had behind the barn. So that's his identification, all right? So for you, this might be sample 1. It could be a specific, could be your garden. It could be front field, front pasture field. It could be your alfalfa field or whatever case might be. But you need to, communicate with us as best you can so that when we document this on a sample, you can very easily say, okay, I know exactly what sample that particular is and the results of that field. All right. I'm going to jump down here about towards the bottom, and this is 3 acres. We see that the primary crop is alfalfa grass, and this is an annual top dress. So this field is for hay, okay? And the previous crop was alfalfa grass as well. So in this case, a hay field made up of alfalfa grass, and it's going to be something he's just going to test this and see how much fertilizer, if any, he needs to put on for the growing season. All right. So let's take a look at it. All right. These numbers in this left-hand lab results may not need to mean a whole lot for you, but for the university and how they test the soil, they will mean a lot, okay? In this case, phosphorus levels is 42. In reality, that means there's 42 actual pounds of phosphorus per acre in this field at about a 4-inch depth, okay? And based on that, and based on the fact that it's alfalfa grass, the computer system will say, okay, at 42, the level of accuracy is in the medium range. So the fertility range in this case for phosphorus is medium, okay, at a number of 42. If we look at potassium, we see a much larger number at 272, and that number represents also a medium fertility, mainly because it takes a lot more potassium in the soil for alfalfa. That number has to be larger in order to basically be in a level of low, medium, and high, so to speak. So in this case, at a potassium level of 272, the computer automatically says it's in the medium adequacy or fertility range, all right? Okay. One, if not the most important analysis on this is the soil pH, all right? And from that, and from the buffer pH, the computer system will basically make lime recommendations. In most soil samples, a pH of a 6.3 is not often going to require any lime, but alfalfa in this case requires a much higher pH. Therefore, in this particular soil sample, it calls for 3/4 of a ton of lime, okay, in this case. So I'll explain that a little bit later. So those are some of the things that I look at very quickly as an agent. And so that lab is going to make the recommendations of 40 pounds of phosphorus and 160 pounds of potassium for this on this field for this coming growing season. All right. So in case, let me see, yeah, this is a sample back in March of 2017. So these would be the recommendations to put on this field for 2017 during the growing season, okay? And I'll explain this a little bit more. All right, here's where I come in to play, okay? Or horticulture agent, or whichever the case. Once I see these results and these numbers, I basically come back and make specific recommendations of a specific fertilizer or fertilizers. In this case, it called for 3/4 of a ton of 100% effective lime per acre. Now, I'm going to come back to this in a minute, but the soil samples that I basically asked for acreages, it's based on how much lime, if any, is needed based on 100% effective lime. So we'll talk about that in a minute. In this case, I've told the farmer, test calls for 500 pounds of O1030, which is a fertilizer for alfalfa that contains boron. So the agent, whether it be a hort or ag, will often make specific recommendations in pounds per acre or basically pounds per 1,000 square feet in horticulture examples, okay? Boron happens to be a micronutrient that's needed by alfalfa. So the computer system and I understand that. So I'm going to tell the farmer, okay, this is what you need, but if you applied boron last year, then basically you have alternative sources of fertilizer to supply the phosphorus and potassium. I don't want to get you mixed up on that, but basically it's part of my final recommendations for alfalfa. All right. What's below as far as the comments will give you, the individual landowner, the farmer, etc., a little bit more information about that individual results. So in this case, we see information about the lime and how it distinguishes about how much liming material is needed. Also tells you about the importance of boron, okay? And then it also talks to you about if you need nitrogen, and if so, how to determine that. So that will give you some additional information for your sample. So when you get this, being able to interpret all of this can be quite a chore. But from my perspective, if you know how much, if any, lime to put down, and if you need to know how much and what type of fertilizer to put down, then that's important. Now, if you're looking at small acreages, small areas, then maybe manure and compost comes into play as your nutrient source, and we can work with you on that as well. All right, here's a sample of basically a home lawn, okay? Once again, it's number one, it's the front, so it's probably the front lawn. We look down here, plant to be grown, it's tall fescue, and the location is a home lawn. So this sample is going to look somewhat familiar with the one we had for alfalfa, but in essence, you know, the numbers still represent what that plant might need for that growing season. So in this case, phosphorus and potassium are in the medium fertility range. Soil pH is 7.6, which is pretty high. Okay, when we get above 7 in our area, we often start to get into some little bit higher pH ranges than we normally see. Right? In some cases, I may be looking at the buffer pH, which is another way of determining how much lime, how much buffering capacity that soil has, which is another way of looking at pH. Calcium and magnesium are not always all that important. In some cases, I'll take a look at those. Zinc, on the other hand, I often look at that if we're raising corn, okay? Corn is has a need for zinc, and at certain pH levels, it can become inadequate. So we compare that if we're looking at corn, right? Once again, it's going to give you additional comments. The agent's going to make some recommendations, and the computer system's going to kick out how much fertilizer, if you selected, let's say 10, 10, 10, which is a very common fertilizer for small homeowners, how much of that you would be putting on per 1,000 square feet. So you can see you're looking at, in that case, 10 pounds per acre to get you a pound of nitrogen, a pound of phosphorus, and a pound of potassium. And we'll go over these numbers next week. All right, same thing with the garden site. But here we see the garden was low on pH, 5.7. And in this case, it needed some lime. And the lime recommendations is 50-pound bag of lime per 1,000 square feet. So we're not looking at tons per acre here, but we're looking at so many pounds in this case per 1,000 square feet. 1,000 square feet is going to be a 50 by 20 foot square or an area, okay? Length times the width will give you square footage. So you can actually do a rough estimate on the width and the length, it'll say, of your garden site, and calculate how many 1,000 square feet you've got in your garden. Need help? We can always help you there. Another thing is we're looking at soils, and you really want to get more in depth on soils, is you can go to the Web Soil Survey, just Google that, USDA, NRCS, like Web Soil Survey, and it'll pull up, and you can type in addresses, etc., and you can actually get right down to your soil in your front yard or your back 90, so to speak. And it'll actually kick out information about that soil type based on previous soil work that was done literally years and years ago when they surveyed all the soils in the United States. So you can go to that website and get that information at your fingertips, okay? What you're going to get is more of an aerial type of photo like the one on the right, okay, is a good example. So this might be the boundary for your farm or the land that you may own. And as you see within that boundary, you've got different numbers and different outer delineal lines within that boundary. And that will distinguish between the different soil types within that area. So, if you've got an acre, 2 acres, whatever, you might have same soil series, same soil type in there, or you might have 2 or 3 different ones. So that will help you if you want to really get into what soils might be in your county, into your area, etc. All right. When we're looking, all right, let me see, any questions on that? Any questions that is a follow-up there on the soil test analysis? I can work with you. Sarah Stoltz in the office can work with you on what those recommendations mean if you are not familiar with those printouts that you might get from a sample. Once again, it takes about 2 weeks for us to get the samples back once we mail them out from the office. This time of year, maybe less than that. Any questions you might have?
You mentioned alfalfa as a cover crop needs a relatively high pH, not a low pH. Are there cover crops you'd recommend where you want your soil to be acid in nature?
Well, and it really depends upon the cover crop. Well, first of all, alfalfa is not, it's usually a permanent crop that we would put in, usually for hay or could be grazed. Cover crops, on the other hand, I might have mislabeled that. Cover crops are usually things like wheat or rye crops, can be other crops in garden sites such as, late producing crops like leaf type lettuce and stuff can even be used as a cover crop. But mostly wheat is a cover crop for garden sites. But usually those crops, and they'll vary, but mostly they are going to be most effective in their growth and production and slightly acid, 6.2 to 6.8, okay, a pH range. Not a lot of variation within those crops as far as pH, but not very acid at all in that case.
Thank you.
And we deal more with acid soils here.
Oh my gosh.
Once in a while, I'll get a high pH number come back, okay? But often, I would say for every one high pH above 7, I'll probably get 30 or 40 that's more acid, okay?
I'm texting.
All right. When we're looking at soil acidity, all right, and we'll get into the pH scale here in a minute, but where does that come from? Well, most cases it comes from, how organic, as it decomposes can create some acidity. As a general rule, clay soils are often more acid in nature, okay? The clay particles, for example, contain, they will absorb and hold more of the hydrogen, which makes acid, and so just the hydrogen ions themselves will create acidity. Sometimes leaching of cations, and these are basically when I talk about cations, I'm talking about the individual mineral that's within the soil. So we have some leaching or crop removal.
No, it was not phosphorus. So.
Can't do that. What's that? Someone said, okay. Acid rain and acid forming fertilizers are also a good source of soil acidity. So if we're looking at even some of our ureas, and when we had ammonium nitrate a few years back and put on that as a nitrogen source, it really had a major impact on soil acidity as well. So those are some of the things that will create acid type soils, okay? So why do we want a lime, okay? First of all, the pH values less than 5, okay? We have a lot of the soluble aluminum and iron and manganese can become toxic. And we'll show this in a minute, but as we begin to get into lower pH soils, it creates a toxic for some of the more soluble minerals that are in the soil, all right? Lime supplies calcium and magnesium, which is often what lime is made of primarily, okay? Is a lot of calcium and sometimes magnesium. And calcium is good for plant production, okay? And availability of a lot of our major essential nutrients, such as nitrogen, phosphorus, and potassium, basically increases with pH or decreases as we get into often a very low pH, or in some cases a very high pH. So basically having a pH in that 6.2 to 7 range is for the most part important, except for areas that, such as the specific crops that might require a low pH or a high pH. And then the microbes that we mentioned earlier, the earthworms, fungi, and the bacteria that make up of the soil, they often perform well if soil needs to have some lime, okay? Legume crops such as clovers, alfalfa, which is the two biggest ones that we have. We get into some other beans, for example, in garden sites that might be a legume crop, and they have the ability to take nitrogen from the air and fix that and help produce their own nitrogen, okay? Soybeans is another legume crop that's out there. I think as you look at this sort of puts things in perspective, okay? If you're able to to look on the left-hand side, we've got a pH range of 4.5 to 8, okay? Keep in mind that 7 is neutral, okay? Above that is alkaline, okay? And below that is acid. We deal more with acid soils and alkaline soils, but in this case, these individual colors are labeled, and then as you see, they widen out and they narrow out depending upon the soil pH. So let's just take the nitrates, for example, okay? Nitrogen in the soil, in whatever form, is more available at a pH, let's say at a 6.5, all right? If we had a very low pH of 6.5 or less, the availability of the nitrogen is dramatically reduced. So in this case, if you know this, and if you know you've got a low pH, then we may be having very ineffective use of some of our nitrogen that we might put on for growth. All right, so understanding that. Not so much with potassium, which is just below that one there. All right, not a great variation unless you really get way out here on the far end of the pH scale. So it is fairly much available at a fairly wide range of pH. Skipping down the phosphorus here, availability pretty much the same, okay? Not a great deal of difference in the availability, but we still see some level of availability increase in that 5.5 to 6.8 to 7, right? Now, one of the things we get into, if you look on the left-hand side here, aluminum, iron, and magnesium, or manganese, those can become toxic, okay? So if we have a low pH, it drops down around this 5, let's say, unless that plant needs these elements, they can become toxic. So aluminum, iron, manganese can, in some crops, be, toxic because they're absorbed more readily at the lower pHs. Right? So having a little bit of that knowledge will help you understand as you look at your individual crops and crop situation where that pH range can impact growth and production, okay? So if you've got a pH, down here below 5.5, you're already starting to impact production, growth, or yield just from the fact that the pH is lower. You can put on additional fertilizer and you'll get very little response from that. So just keep that in mind, okay? Any questions about that before I move on? Because that's sort of important to understand. You don't have to always understand the specific element and where it falls in that pH range, but understanding that the pH will have a dramatic impact on availability and how these plants absorb and use different nutrients, right? Okay, everybody okay with that? So lime in itself, the liming material that we have here in northern Kentucky and in most of Kentucky is calcite lime. It's calcium carbonate, okay? And a lot of people think it's the calcium in that limestone that basically, raises the pH, but it really is not. As you can see here, it's the oxides. It's the calcium here. The carbonate is the oxide of this particular liming equation. And what happens is that the oxides take the hydrogen, which is really the positive hydrogen ions, and they kick those out of solution. So they combine with those and they actually form water, okay, as the pH, or excuse me, as the calcium lime begins to interact with the soil. And as we basically kick these hydrogen ions out of solution, we actually raise the soil pH, okay? And it's the hydrogen ions in the soil profile that make soils more acid, all right? I will say this, I didn't mention it earlier, but a pH level of 6.5 versus a pH level of 5.5, it's only one number, okay? 5.5 to 6.5. But in reality, a 5.5 pH is 10 times more acid than a pH of 6.5. So there's a linear increase there, tenfold for every full pH reduction we might have, or increase in that. Okay, so those numbers, you know, are dramatically different from a 6.5 to a 5.5. All right. A little bit of chemistry there, not overly. Now up north, we get into limestone rock that will have quite a bit of magnesium in it, and that's called dolomitic lime. And you can see in the chemistry equation there, the magnesium is available. And that lime will often be have a higher value as a liming agent than the calcium carbonate, calcium lime that we have mostly in Kentucky here. All right. Okay, when you're looking at lime, not all lime is going to be the same, okay? Calcium carbonate equivalent, CCE, is actually looking at the quality of the individual limestone rocks that are ground up to make lime. So all limestone rocks are not equal, you know, in their quality and the amount of calcium carbonate that they may have. So it says here that pure calcium carbonate, pure high quality, you know, lime is going to be around, have a CCE of about 100, okay? That's a number that they can give it, okay? And so you can see there that if, you know, the magnesium actually raises that CCE up to a little bit in that case. Now, maybe as much as anything, the size of the lime particles that we are purchasing will have a major impact on how quickly this lime interacts with the soil and dissolves and increases the soil pH, okay? So in this case, lime in Kentucky, there's guidelines, and lime is checked 2 times a year by the Kentucky Department of Agriculture, and it's checked for its quality and it's checked for how fine the lime is being ground. And we're able to provide some value for that lime based on those 2 bits of information. So if you can imagine, you know, a 10 mesh screen where the holes are 2 millimeters in size, you know, less than a 1/16 of an inch here, if 50% of that liming material goes through that, it's 50% effective, okay? What will pass through that 50 mesh screen will be 50, but will not pass through a 50 mesh screen. So that basically gives you a 50% effective. Now the lime that passes through a 50 mesh screen, which is a very small opening, is going to be 100% effective. So you get into the point where, you know, depending upon the query and their individual crushing machines, how fine they're able to grind this material as it goes through there, okay? So keep in mind that that becomes a part of the equation needed to calculate the quality of the lime. All right, so all the particles that don't pass through that 10 mesh screen, okay, which is going to be about a 1/16 in size, is they're going to give it basically a 0% CCE range based on the fact that it's going to take it at least 3 or 4 years to even start to dissolve. All right? So what does all that mean? Well, another thing we look at, and this will all make more sense here in a few minutes, another number that we get from the rock quarries and from the Department of Ag when they test the lime is a RNV number for every lime source, okay? And you can go online and get those numbers for every quarry and where every quarry that would basically sell a liming product, okay? So those numbers can be as low as 30, 35, and as high as maybe 80 RNV numbers. So, and it's based on the quality of the rock and how finely that rock is ground. So those things determine a true quality number for that, okay? Another thing, if you're looking at a liming agent and you want to pick a lime that's going to react as quick as possible, you're going to need a very fine lime. You're going to need a lime that has a very high RNV number if you need to raise the pH up on a fairly short period of time, okay? And this may correlate with the crop you're trying to grow and the timeline that you're trying to basically work with, okay? When you're also looking at considering a lime product and especially larger quantities, transportation, cost of the lime, what it costs per ton, and even whether the lime has been stored outside where it might get rained on or inside. And those are things that you need to know and to figure into the calculations of what lime might be best in your situation. Now, if it's a small garden site, small 1,000 square feet, then basically you're looking at going to your local garden store, your feed store, or whatever, agriculture store, and buying some bag lime for that purpose. All right. Lime can be applied at any time of year, but the fall is often considered the best, okay? What that does, it allows that lime to interact with the soil if you need to raise that pH up, and it, in essence, that pH is in a better potential area for production the following year. Now, if the lime is fairly coarse, if and the RNV number is relatively small, meaning probably less than, let's say, 50 or so, that means that that lime is fairly coarse. And that coarse lime can take at least 2 years before it's totally, basically, made available as a soil amendment to reduce the soil pH. So it may be a gradual decline in pH, but it will eventually stabilize over a period of a couple, 3 years, okay? But if it's a real fine lime, it will react usually within the first 12 to 16 months. Another way that you can increase the lime and how effective it is to till it in. It's not always possible, but if you've got a site where you can till the lime in to the soil, incorporate that into the soil profile, then that's considerably better than just putting it on the top of the soil. Okay. If you put it on the top, it's only going to move down into the soil about an inch, inch and a half a year. And that will depend upon moisture content, and the fineness of the lime will have a big factor in that. But changing that pH will take a few years on a larger scale, especially if you have a pH below 5.5. All right. Regular soil testing is suggested. You know, once you put lime on, give it a couple years and come back and recheck that pH, see how much it has increased, and see if additional lime might be needed. Okay. Liming materials, okay. Of course, it's made by grinding up the limestone. The finer the pockets, the important it is, but we're looking at pelletized lime, and that's usually something you'll have to buy at a farm store, at a garden store. It's basically bonded together by that lignin sulfonates. Okay, close enough, right? So it's a bonding agent that basically takes that finely ground particles and actually makes it into a coarser particle that's easier spread, okay? And is it a higher quality lime? Well, it is made from a real fine, high RNV lime, but once they put that coating on it, that really slows down the reaction time because it has to dissolve that external bond. So the surface area of that lime, it may take a while to break down before it starts to interact. Therefore, the reaction time may not be increasingly faster than normal lime itself. This lime is going to be fairly expensive, maybe as much as $160+ a ton right now. If you're buying 1 or 2 bags, that's not a big deal. But if you're trying to apply 2 or 3 tons per acre, then boy, it's not an economical way to supply a lime. All right, this is something that I do for all of my agriculture samples that I send out. It tells you where the local lime sources are, okay? So Pendleton County used to have a lime that they would make available to truckers or to farmers, okay? About 5 or 6 years ago, their equipment got old and they did not want to update that. They changed the side of the road where they were processing their aggregates. So they basically quit making agriculture lime. But what they do sell is what's called lime sand, all right? If you follow my cursor there, lime sand is a byproduct of their crushing process. So they crush limestone rocks into smaller sizes to make different size stones that they will sell. You know, number 2 rock versus 610s versus 57s or whatever. So in that process, they have chips and fine lime that come off of that grinder, and those is what makes what they call lime sand. And that can be tested. And I think this test might have been 37, RNV 37 was maybe, it says March 2019, but that might have been even a year before that. So that's not a very high number, okay, compared to Bourbon County lime here. And their lime is RNV is 70, 37 compared to 70. All right, so a much higher quality lime in Bourbon compared to Pendleton County and to also Fleming County and to Scott County, which for the most part is our closest lime sources, right? I've even broke it down at that time. There's a price per ton, okay? And it doesn't vary that much, okay? Some of the cheapest lime being in Bourbon County at 9 1/4 a ton at that period of time, that was the greatest quality. Therefore, it would take a lot less of it for liming agent. All right. Another thing I do with agriculture samples, this would not be too relevant for 1,000 square foot type samples, but for acreage samples, okay? Let's go back and just assume that a soil sample came back and it called for 1 ton of lime per acre. And that 1 ton is listed on that soil sample represents 100% effective lime, okay? So in order to compare the different liming sources, it has to basically compare as 100%, okay? So if I am looking at the Bourbon County lime, okay, which is 70%, if I go across here, to get 1 ton of actual 100% effective lime, I've got to put down 1.4 tons of bourbon or pelletized lime per acre, right? On the other hand, if I am going to get that same 1 ton and go out here to Butler with their lime sand, it takes 2.4 tons to get that 1 ton effective lime, okay? And the reason why it takes so much more is because the RNV value is considerably lower. Right? So that's some terminology, that may be helpful to you, especially if you're farming and you begin to get into a larger number of acres that you're trying to apply, and you're needing to haul a good amount of lime to a given site. And then the cheapest lime may be the most expensive lime, or the lime that has the highest RNV number, okay? There is a calculator here, and I've given you the web link to that will allow you to go in and compare different limes, sources, plus transportation, and it'll tell you what it's going to cost you per ton based on the lime source and transportation of that if you have to haul it yourself. So I did have a good number of farmers this year. They work with Chambers, and I don't mention that particular trucking company for a specific reason, only to say they were making back hauls to Campbell County. They were going into that Paris, Lexington area instead of coming back empty. If you work with them to do a back haul, that's what we call that, they could stop in at Bourbon County, for example, or Paris, or Scott County, and pick up lime, and they can basically, you can save money that way, okay? You can save money that way. All right, so there's a calculator that can help you with that. All right, we do have a lime spreader in Campbell County. When we bought this 12 years ago, we bought it so it would go on slopes. And that was, I knew that if I bought a big 8-ton unit and Farmer Joe out here put 8 tons in it and tried to get out on some of these slopes, that there would be major accidents and potential death due to some of this. So this is a 3-ton unit, and that's what it looks like behind a 100 horsepower tractor, okay? So a big tractor pulling a small toy, what it looks like. But in that case, that was about a 10-acre field that I limed in about 2 hours, okay, with that 3-ton unit. And I was putting on upwards to 4 tons an acre on some of that. So I was making a few trips out there. So, and you can see the grass here in that photo is pretty much white with lime. So it basically had a nice uniform spread on it, but that is available for farmers. Southern states presently leases that piece of equipment out. All right, a few more slides and we'll turn it over for some more discussion questions. Soil pH. Okay, as we begin to look at that, the pH range between 6.2 and 7 for most crops is the most ideal pH range, okay? Not all crops, we have a good example here tonight that's with us, that's growing, in this case, blueberries, and they are one of a few crops that really like low pHs and thrive underneath of those, mainly because that crop needs a lot of iron, and with the low pH, it is able to absorb additional iron out of the soil. All right, so at a pH range 6.2 to 7, best pH range, nutrients are more readily available, best crops for root growth, reduction, and for our legume crops for fixing nitrogen is maximum rate there. Once we start to drop down 5.5 to 6.2, we start to see some negative effects for a lot of our crops, but not all of them, okay? In this case, we have reduction in fertilizer efficiency. We can throw the fertilizer on these fields and and it's just not effective, okay? Doesn't necessarily mean we've lost that fertility, but absorption of those nutrients is not very effective in the lower pH range. Herbicides, in some cases, especially our triazine, atrazine type products, are somewhat limited not much of a factor here in Campbell County unless you're growing corn, okay? On the other hand, if you're raising legume crops, the clovers, the alfalfas, if you've got basically soybeans or some of those crops, you can see a 10 to 30% reduction in this pH range from those, okay? On the other hand, our corn, our fescues, our grasses are not basically impacted until you get below a 5.5 pH. So that acid, slightly acid to moderate acid pH range there isn't going to impact the individual fescue plants that much. But keep in mind the fertility and efficiency there is reduced, even though the plant itself can still handle that low fertility or low pH. Now, once we drop below 5.5, okay, then we can begin to see some fairly significant and severe problems at these lower pHs. The crop is not going to be very productive. We may lose as much as 50% production. A lot of that's due to just the root growth. It's dramatically reduced. The roots are sort of pruned back by the acid in the soil. We can see some toxic micronutrients such as aluminum and iron in that situation. And we can begin to lose stand. Our crops that we want to grow become thinned out. And guess what's going to replace them? Often weeds, okay? So that's basically where we're at. Now, that sort of winds me up for this session. Now, next week, we're going to get into looking at the nutrients, N, P, and K, and the importance of those, and how to manage those for some different crops. We're going to look at manures and looking at the value of that. We're going to look a little bit at soil compaction and how to manage that as well. So we're going to look at the production side of the soil a little bit more next week. So are there any questions that you might have? Because I want to escape out of this. I'm going to stop sharing. All right.
I was wondering, Don, if there are sources of, pickup truckload of sawdust that in the area. Years ago, there was someone near us in Benham Hill Road that had a sawmill, and I got a pickup load of sawdust from them, but I don't know if the sources have dried up. Know of any?
Actually, when you're looking at sawdust, you're really going to have to deal, in essence, with somebody often that's supplying sawdust for horse farms. So I've got a couple individuals that are in Campbell County, or maybe even closer to what county you might live in if you're not in Campbell. And
We're in Campbell, yeah.
You're in Campbellfield?
Yep.
And so they would know readily where sawdust is available. Now, sawdust is often a product out of sawmills and et cetera. So you go to Maysville, Mason County, Round County, that direction, you might get into availability. But, I could probably give you a couple of contact names and phone numbers, and you'd be able to pick up their sources of sawdust. Another option for you might be to get compost, okay, from these farms that bed their horses with sawdust. And so you're getting organic matter, fertility, and that high carbon product in the product there. Not for sure it's going to work for you in your situation, but it might. Okay, it surely.
That'd be great.
Yeah, and once again, these horse farms, and I can give you some names on those. Do you have my email, Phil? Or phone number?
We can get it.
All right. Let me give you the office number if you want to write this down. Anybody else, I'll give you my office number and cell phone number as well. Office number is 572-2600. And my cell number is 250-6665. 250-6665. And the office is 572-2600. Hope I gave those right. All right. So that'll get me you can talk to me, and then I can get you more specifics to address your particular issues. All right.
Thank you.
All right. Anybody else?
Yeah, do you have a recommendation for a green manure for a small garden with fairly high clay?
Okay.
And then I could sow this at this time of year.
All right. I'm looking here. I'm going to stop my